Imagine a star that died millions of years ago, but instead of fading away, it came back to life, spinning faster than your kitchen blender and emitting radiation beams so powerful they could sterilize entire planets from thousands of light years away. Welcome to the terrifying world of pulsars, cosmic zombies that defy everything we know about stellar death. These aren't your average dead stars quietly cooling in space. Pulsars are the reanimated corpses of massive stars, and they're spinning with such insane velocity that they've become some of the most precise clocks in the universe. So what exactly are these stellar zombies? Pulsars are actually neutron stars, the collapsed cores of stars that went supernova. When a star much larger than our sun runs out of fuel, it doesn't just fade away. It explodes in one of the most violent events in the universe, leaving behind an incredibly dense core compressed to the size of a city, but containing more mass than our entire sun. This is where the zombie analogy becomes terrifyingly accurate. These stars are technically dead. They've exhausted their nuclear fuel and should be cooling remnants. But conservation of angular momentum works its magic. As the star collapses from something the size of our solar system down to just 20 kilometers across, it spins up dramatically, like an ice skater pulling in their arms. The result? A cosmic corpse spinning hundreds of times per second. The fastest known pulsar, PSR J1748 to 2446 AD, rotates at an unbelievable 716 times per second. That means a point on its surface is moving at about 24% the speed of light. But here's what makes them truly pulsars, and where the danger lies. These neutron stars have incredibly powerful magnetic fields, trillions of times stronger than Earth's. As they spin, these magnetic fields channel particles into beams that shoot out from their magnetic poles. And if those beams happen to point toward Earth as the star rotates, we see a pulse of radiation, hence the name pulsar. It's like a cosmic lighthouse sweeping its beam across the galaxy. But these aren't gentle light beams. We're talking about radiation so intense that if you were within a few thousand kilometers, you'd be vaporized instantly. The energy output is staggering. A typical pulsar emits more energy in 1 second than our sun does in an entire year, and they're incredibly precise. Some pulsars are more accurate than atomic clocks, with rotation periods that vary by less than 1 part in a billion. This precision has made them incredibly useful for astronomers. We've used pulsars to test Einstein's theory of relativity, map the structure of our galaxy, and even include them on the plaques aboard the Voyager spacecraft as cosmic signposts for any intelligent life that might find them. But the most mind-blowing aspect might be their density. A single teaspoon of neutron star material would weigh about 1 billion tons on Earth. The gravity is so intense that if you dropped a marshmallow onto a neutron star from just 1 meter above its surface, it would hit with the energy of a nuclear bomb. These cosmic zombies are everywhere in our galaxy. We've detected thousands, and there are probably hundreds of millions more. They're the ghosts of massive stars past, spinning their warning beams across the cosmos. And while the nearest known pulsar is safely distant, their existence reminds us of the violent processes that shape our universe. The really fascinating thing is that pulsars eventually slow down as they lose rotational energy. After millions of years, their pulses become weaker and more spaced out until they eventually fade into silent neutron stars. But during their active phase, they're among the most extreme objects in the universe, stellar zombies that came back from the dead with a vengeance. Which cosmic phenomenon freaks you out more, pulsars or black holes? Drop your thoughts below and follow for more mind-bending space facts.